Thank you. Thanks very much for the opportunity to share this exciting work with you. And let's get right to it. So first of all, this is an open edX conference, so just to make sure that we're all on the same page, what is Jupyter? Jupyter is a set of open source tools. There's a whole really collection of tools for interactive and exploratory computing. It's used very broadly in data science fields, and it consists of several key components. At the heart of the Jupyter ecosystem is the Jupyter Notebook, a document format that allows you to mix together multimedia content, text, formatted equations using LaTeX, markdown content with code that is executable via a connection from the browser to your Python engine or another language. There are other tools like Jupyter Hub to provide a cloud service with Jupyter, and also tools for education like NBGrader, which is going to feature prominently in our talk. And here is an indication of how incredibly Jupyter has been growing. This graph shows not the number of files with the .ipynb extension, but the number of actions that a user has taken with such a file. Because there's a lot of duplication on GitHub, of course, and so if you just count the number of files, it's a biased metric. But this indicates a number of monthly users that actually have touched an ipynb file compared to R and MATLAB, which are two also very widely used programming languages in education and in some engineering and so on. Now, I have been using the Jupyter and its predecessor, the IPython notebook, in my teaching practice for many years. This is a first course that I published in 2013. I had been teaching it before, but in 2013, in my circles of engineers and so on, computational scientists, it's got some traction, and people like it very much. It's a collection of 12 Jupyter notebooks that teach students how to come from having practically no programming experience to being able to solve the Navier-Stokes equations, which, if you have heard about them, it's not an easy task. Now, over the years when I've been using Jupyter notebooks, and it's been now several years, I've developed this summary idea of what it is that is so powerful about using Jupyter in teaching. And this is the idea of computable content. I say the idea of creating educational content, creating open educational resources is the term of art, OER, that are made powerfully interactive via compute engines in the learning platform. So this is the idea, the overarching idea that I have as a vision for using computing as a tool for teaching technical topics like mathematics, like physics, like engineering, like chemistry, and so on. And whoops, I have a black slide for some reason here. It's supposed to be a demo. I wonder what's happening. Let me just turn on mirroring. Maybe that'll help. Mirror displays, and let's see what that does. So this slide gives you a short link to a demo that I wanted to share for you. It's one lesson of a number of lessons that we wrote last semester for a course. It's an introductory course in engineering computing. And so if you go to go.gwu.edu, GWU is my institution, /engcomp3 is module 3, lesson 1, you'll find a lesson, it's called Catch Things in Motion, that is attempting to explain physics problems using this idea of interactive computing in a Jupyter notebook. So the first thing that students are going to do in this particular lesson is use a video that has been published by MIT, capture a frame of that video, and then capture mouse clicks through events on Matplotlib. The plotting library of Python has the ability to capture events, and we capture mouse clicks of this strobe image of a falling ball. Then the students are able to get the coordinates, the coordinates on the frame, on pixels, and then they're guided through the process of turning that information into y, the y coordinate in meters, because we know the distance between those two white lines, and there's several steps of the way that leads the students to calculate the acceleration of gravity. So this is teaching a physics concepts through a process where you're using computing, you're teaching computing programming patterns at the same time as driving into a conceptual development of, in this case, motion, the essential physics problem. This is an example that I want to share with you. If you had time to pull it up, then you'll scroll down and see the full lesson. But there's a wealth of material that people have created as Jupyter notebooks that people are sharing on GitHub. And this is the gallery of interesting Jupyter notebooks is one place where you can find links to courses, lessons, and even whole textbooks that have been written with Jupyter in machine learning, statistics, biomechanics, geophysics, and all sorts of technical fields that people are teaching using computing. So it really is exploding in education, and Berkeley, UC Berkeley has made it the centerpiece of their Foundations in Data Science program. And they started this pilot in 2015 with their pilot course for about 100 students. Freshman students coming into UC Berkeley. The second run of the course, they had 400 students and so on, 700, and now I believe that they're teaching 1,200 students and aiming to teach all of their freshman class at UC Berkeley the Foundations in Data Science course with Jupyter Notebook. So I really encourage you to read that article, that press release from Berkeley that explains all of their process for this initiative that they have, all centered around using Jupyter for teaching. Now, the course that I gave you a sample lesson before. It is part of this module that we've put on Open edX. This is a self-hosted, self-produced online version of a one-third of a course. So the whole semester course is 3 modules, and 1 module is now online as an online course on Open edX. Here is the short URL to that course on our Open edX site. But the whole course was first written as Jupyter Notebooks. So the whole material was developed as Jupyter Notebooks. Jupyter Notebooks is our authoring system for writing this executable textbook, all of the materials that are being shared with the students and used in the classroom. So we wanted to develop we have this online version on Open edX, and we wanted to develop some degree of integration between the Open edX platform and the Jupyter Notebooks. So Michael here at IBL has been working, well, their whole team has been working with us. They have been our technical partners to develop 2 XBlocks. The first XBlock, Jupyter Notebook Viewer. Here's the concept. The idea is, my vision is that as an author, as an instructor, I want to write my course on Jupyter first. I want to create that on GitHub and actually collaborate with other people and have version control on my notebooks, and that is the source of everything. And then I can publish those online, and what does the XBlock do?
So what the XBlock asks you for is the URL to the notebook, right? And that's not the, with the GitHub wrapper on it, that's the raw file of the notebook. And it asks you for another URL to the images, right? To the directory where you happen to have those images. Sometimes it's in GitHub, sometimes it's not. And then it renders it dynamically into Open edX. Now, one important consideration there is that a unit in Open edX is, and this is the credit to Lorena, but a unit in Open edX is meant to be considerably shorter than a notebook, and many times. Right, so our requirement from the beginning was that we were only supposed to show a portion of that notebook, if need be. Right? If we ever want to show the full notebook, then okay, but more often than not, that notebook is going to contain several lessons, so we're going to just add 2 simple fields to the studio interface of the XBlock, and one of them is going to be your start tag, and one of them is going to be your end tag. So when we fetch the URL, right? We do some pre-processing there. We convert it to the HTML and CSS that looks good in Open edX, and we render it that way, right? And ultimately, aside from being able to edit this on GitHub, right, which has all of the implications of, like Lorena said, of version control, all the permission schemes and everything, you're also able to display code in a way that actually looks good in Open edX.
Here's a screenshot of a section of a lesson. So like Miguel said, and we've talked about this a lot, I've developed several courses now using Jupyter, and I know a lot of people that develop courses using Jupyter. People write a whole lesson in one notebook, and a whole module might be 5 notebooks, 6 notebooks, but a notebook, if you print it out or do an HB convert into PDF, it's going to be 5 pages, 6 pages. You cannot put a whole notebook as a unit. So the Open edX platform breaks up the content into sections, subsections, and units, and you need to be able to show portions of a unit, create a learning sequence from the material that comes as a notebook. So I author the material as a notebook and then create a learning sequence with portions of that notebook that I actually can also interleave with some, this screenshot doesn't show you, but I could show it, but I could interleave some multiple choice questions or a little video or something to create a learning sequence. In this case, I want you to look at this. This is being shown inside the Open edX platform, and you can see, of course, highlighted code, syntax highlighted code, and you see the output of the code, in this case some plotting, rendered without any additional effort from the point of view of the Open edX side. I'm just giving it the URL to the notebook. And the second, and this is really amazing, we're really excited about this. This is the second X block, the ability to create assignments that are auto-graded from Jupyter Notebooks. So as an instructor, I create a Jupyter Notebook that is an assignment. I use the NB Grader extension to create my assignment where the student might have to write pieces of code to answer the question. And as an instructor, I also write tests, essentially unit tests, that will be hidden when the notebook is processed by the NB Grader extension to deliver the assignment to the students. Then the student solves the assignment and uploads it back to the Open edX platform. It gets automatically auto-graded, and some technical things that I'm forgetting. A Docker container is started at the moment that the student uploads their notebook. The instructor creates a requirements.txt file to make sure that all dependencies are available, and it gets auto-graded. The student receives an instant report of their scores, and the score gets written into the Open edX gradebook. Okay, so screenshot. Did I forget anything you want to say about the technical side?
Well, I mean, the Docker component is significant because the reason it's there is that when a student submits something to be auto-graded, right, we spawn a container for that user for that moment only, right? So when you're building the course on Studio and you upload your requirements.txt file, you say, okay, well, this program is going to be utilizing, I don't know,
NumPy or Pandas or...
Yeah, and then the idea is that the instructor Lorena can specify that through the requirements.txt file. So at that moment, we build a Docker image that has that NB Grader with those requirements ready to go. Now, when the student submits it, then we spawn up a container, we run the grading, and then we tie the grade back into edX. But that container is isolated from the rest of the platform because we don't want to have any problems there.
And there are several ways that it's contained. One of the configurable options from the instructor's point of view on the X block is the maximum number of seconds that a cell is allowed to run. So, I can create an assignment. I know that the student is going to be running very simple code, and therefore any cell should not take more than, 5 seconds or something. And we set that limit. So, because certainly when the student uploads a notebook, that notebook could contain any code, any Python code, and we just, it throws an exception if it goes over the time. Yeah. So here's a screenshot. This would be from the point of view of the student, how they would see an assignment. This is my real course where we've actually put in the assignment yesterday with, we created an assignment using NB Grader. And this is what they would see. They would see some instructions, and they would see a link to download the notebook that is the assignment that they have to solve. They do have to use their own Jupyter installation, whether in the local machine or in a cloud service. We're not providing cloud computing that is tied to the course at this time. There are several issues with that. Cost is one, security is another. We're not providing that because this is an completely open to join and free course. But the student, we give instructions on how they can install, of course, their Jupyter locally, or whether they could use a cloud provision. And so, demo time, okay? This is the exciting part. All right, I want to show you immediately, this is my course, this is the live course. And I've got here the section that I was just showing you a screenshot of. So here is where I've added 2 assignments. The assignments that you were seeing is the first assignment. I was just showing you that. And I am going to let this show for a little bit here, because I'm actually going to copy those instructions so that I could save some time. This is how we normally author, right? Copy and paste sometimes. Copy, and I'm going to cancel here. And I'm going to go to the next unit, which is ready to go here, assignment 2, but it's got nothing in it, and it hasn't been published. You can see this has never been published. This is my live course. I'm actually playing with my live course in front of you. Okay, so we're going to go to advanced and check on graded Jupyter notebooks. That's the X block. Here's my instructor portion to edit. And so, first of all, I could upload here my requirements.txt, but I'm not going to upload it because I already did it for assignment 1, and I have the same requirements here. If I were to re-upload a requirements.txt, it would regenerate the Docker image. I don't want to do that because it takes a few minutes. So just to make it faster for you, I do want to choose a instructor notebook. The instructor notebook, this is, I have it ready here on my downloads, is assignment 2. And that's the assignment going up, and it's now testing that it works. If the assignment, for example, was not well created, click on the assignment on the upload button. If the assignment had some errors and MB grader was not through an exception, then I would get here a big red notice about that. And then I'm going to edit the X block. I'm going to add here the thing that I copied before from the previous assignment. But I know that this assignment is not dealing with string manipulations. It's actually dealing with string methods. That's the second assignment, is a little bit more advanced. But everything else about the instructions are the same for the student. Download the notebook, do what you have to do. So save. Oh, I'm not going to save that yet because I want to show you the options. Here are other options. For example, I could say, 0 is the default here for the allowed submissions. That means infinite submissions. The student can resubmit their Jupyter notebook, and it gets graded again, and the score gets updated each time. Or I could set there a number of submissions, 5, 10, whatever I want to do. Then network allowed, the default is false. Maybe there's one notebook where you might want to allow network access for some specific reason, handled with care. And cell timeout, there at the moment I have 15 seconds, probably too much for this notebook anyway. Whether we allow this, where the X block is going to send back not only the score, but the graded notebook to the student is the option that I have there. The default is false. If we set that to true, the student gets the notebook with the visible tests, so they will actually get a solution. So most of the times you will say false, especially if you have infinite uploads, infinite submissions. And a maximum file size, and we just don't want a student to upload some buggy notebook with, I don't know, like a embedded huge PNG or something. Okay. So there it is. I've just created the assignment with the X block, and I'm going to click on Publish. And there it is. So now I'm going to switch from Safari to Chrome, where Miguel has his Open edX as a student, and is going to show you his experience as a student from interacting with that assignment. Hopefully he can remember some string methods. And his password.
Yeah. So even if this is just string methods, of course, being here makes it incredibly stressful. So great.
You have several minutes because I was talking fast.
Yeah, no, of course. So,
all right, so the right section where we play with data in Jupyter, where it says test yourself. Good. Assignment number 2 is now live. Of course, you can go to our course right now, and if you have Jupyter on your machine, you could enroll, go to that section, download the notebook, solve it in your Jupyter, and see if you can get a grade. Oh, no, you have to no, that's my session, so you have to change that, and you can, okay, fine, good.
Yeah.
Delete mine, and yeah, good, right. Good. Good job.
This is not my own. Thank you.
You don't need to go to terminal because I already loaded Jupyter there.
Oh, fantastic. Okay.
So now you have to go to the downloads location to find it.
Oh, great. Okay, sorry, I put it here. I
put it there?
Here. Yeah,
yeah. So, okay, solve your homework,
all right.
student. This is the homework. This is how the student sees the homework.
So,
all right. Exercise number 1.
You know, I did this already, but still it's a little scary. So, using the index method, find the index of the first parentheses.
So the student has to, there's a workflow that you have to train your students to do. They have to remove that where it says write your solution here and actually write the solution. You have to execute the cell, ideally. All right. Next problem, can you do a couple and then upload it?
Of course.
All right.
Yeah. Fine. All right, so.
Use the index method, find the index of the second parentheses.
I already named this under the wrong variable. See?
We have to also train our students to follow instructions to the letter because we're using a testing framework underneath. So I say, IDX under -2, that's the variable name they need to use because I have a test, a unit test, essentially, to do the auto grading. So I believe, I'm not going to give him tips.
All right. Okay, see now.
Are you happy with that?
Yeah.
Do you want to do one more?
Do we want to do one more?
Yeah, one more. Do C.
C?
Using the information obtained in part. Yeah, okay, slicing.
So.
Text paren. Good.
Sorry,
Thank you.
Yeah. Okay, so. That, right? And I'm probably going to have an off by 1 error, right?
Doesn't matter because you have infinite tries. You can submit
Okay.
Execute and save. Oops, you have an error.
Wait, what do you mean?
When you set IDX1,
yep.
You're getting text 1 and then index. Who's one index?
Oh my goodness. Yeah, okay, yeah. Wait, up above? Okay, so can you just tell me what to do, please?
He's nervous.
I did this yesterday and today, but
Get rid of the closed bracket at the end.
Close bracket at the end?
Get rid of that one.
Yeah, the square bracket?
Sure.
And delete the first text underscore 1.
The first text underscore 1, that one?
Delete that and,
Sure.
and the square bracket. There you go.
Okay.
All right.
Yeah, now it's not even my grade, now it's all your collective grade, so I don't feel that dumb anymore. So
All right.
yeah. Okay, probably shouldn't have a plus sign there. Boss, do you want to come over here or line 14? Yes, okay, got it. Yes, yeah, learn. I mean.
Right, save it. You can just save it and upload it as you have it right there, and see what happens. Delete that if you don't.
Yeah, all right. I'll
just delete it.
Wow, I feel remarkably stupid right now.
Okay, good.
Right.
It executed. Okay, save it.
Yes.
Okay, save it. You've saved it. Now you need to upload it.
Okay.
All right.
Here? Yeah. Good.
There.
Sure.
Get the right one. So it's from desktop. Okay, good. Upload. All right.
Now we just launched a container. We're running my crappy code. Oh, actually, yeah, we did pretty well. Not really.
All right, so this would be the experience of the student, and since in this case they have infinite tries, they could continue working on the notebook and upload it again and see those red boxes turn into green. Maybe for an exam, you would, if you wanted to do an exam live using this method, you would only allow one submission. Who knows? But those are the options, and I want to show one more thing, which is that it's all open source. So the XBlock is available to download already under a BSD3 license. The instructions for installation are there. And I also want to show you one more. So this is the grading XBlock. Then this is the Jupyter Viewer XBlock. they're all open source, and you can install them in your self-managed Open edX instance. Obviously, at edX.org is not going to be available because edX.org doesn't very easily like to install third-party extensions, but this is the flexibility and agility that you have if you're running your own Open edX instance. And I also want to show you how, this is from my side, the Open edX platform, but I want to show you how the assignments look like. So as I create an assignment, this is my source assignment notebook. It looks similar to what you just saw, but in this part is where I would write the solution, okay? And then in the next cell, we have the tests, in this case, very simple tests that are simply, it's as simple as to get the right element. It's very hard to write smart tests for simple code, but as you do more elaborate assignments, for example, you have a function, you're asking the student to write a function, then you may have a smarter test that is actually checking for something, because here the student can cite if they're smart enough to, I think ahead how the test might work to give it the right answer, I think they deserve the points anyway. So anyway, this is how it looks like. So you have begin solution, end solution. As you run MBGrader on this notebook, you're going to have to select the MBGrader extension, gives you a little extra. This is just being visualized here on the public GitHub, right? Oh, actually, it's a private GitHub with my homeworks. If I have it running on my local Jupyter with MBGrader installed, the extension is going to give me some extra little buttons here that will allow me to indicate that this cell is going to be a graded cell, and that this cell down here is going to be a hidden tests, and then I can assign also the number of points to the graded cells, and I go doing that with all my assignment, and then save that, and that is what you upload to Open edX. That intermediate file where you have already indicated how many points each question is going to be worth, and already the tests have been hidden for the students. So we are open for questions. Thank you. Yes. Please. I have no clue if there's a reason for that. We always... Oh, right. So he's asking, is there a reason why these are two separate X blocks? I have no clue if there's any way to do it as one X block. We never thought about it that way. It was always imagined as an X block to view, to author context. So the first X block means I can write my content, the content that is the reading material, the textbook, content for the student to do the learning. That part is one X block, and then there's another X block for grading. We always envision it that way. Whether it could be combined, I have no clue, but I like it modular like this, because some people might want to just create a notebook. For example, people in adult scenarios, you might want to just provide the learning sequences, and you're not going to give them any graded examples. You have a professional scenario where you trust the learners to just be self-regulated. So yeah, it's more modular this way. Come on, we left time for questions, please. Yes.
So as a student, when I'm going there, I have to log into Jupyter Hub. So how could we ease this? There are commercial products that actually they provide AWS-backed environments. So
that is a total different scenario, right? Yeah. So
how could we make this easier for learners so they don't have to go set up on anything on their machine? So
yes.
Right, so he's worried about making it easier for learners to actually have a cloud-provided Jupyter Hub service, which is the server-side provision of Jupyter instead of the client-side provision where they have to download and install Anaconda, and you have to deal with all different environments. Very important question, very important situation, but we're not solving that, right? We're not solving that. So this is an open course, and it's free for anybody to join. I'm just not giving them free compute.
They have to follow the instructions and be in charge of their own machine or use their own selected cloud provision. This is a live course. I'm going to show you that. Nevertheless, the way that I provide in this course the possibility of having a computable experience is I provide, where is it? Binder buttons. So let me say here, maybe I'm going to go to the next one. I think I have a binder button in every section, but I, at the moment, cannot find it. I think in the beginning of each section I had a binder button. Or at the end, I don't remember. But maybe about the scores, overview. Certainly here in overview I have Jupyter Notebooks, binder. All right, there. So there's so Jupyter Notebooks here, there are links to each Jupyter Notebook. These links go out to MB viewers, so the student can actually read and so on. In addition, I have PDF versions because you can run MB Convert on the notebooks, and so I provide printable versions. The students like to print stuff for some reason. And here is a binder button. So for the free followers of this course, they can use binder, and they're going to have a free service, cloud service provision, okay? On campus, for my students that are on the classroom, I have a Jupyter Hub provided by my library where I have single sign-on university credentials, okay? And I create the necessary behaviors there for them to alternate between the Open edX and the Jupyter Hub. But I can't provide this for free for anybody that just joins my open course. Okay, that's the short answer.
And if I can add one thing, this is not a technical issue, right? So for example, NVIDIA's Deep Learning Institute just launched, and they actually run on Jupyter, right? The difference is that
they have money.
Yeah. So when you press launch, there is an instance that is backed by a massive GPU, and that happens all directly from the learning platform. So the only issue with that is, is the money. So who's going to be paying for that? So,
and the Bitcoin miners.
That's true. That's
if you provide, at the moment you start providing free cloud for people, you're going to get some people taking advantage, and you have to constantly monitor. You have to have a system administrator running cron jobs, detecting whether there's Bitcoin miners and shutting down those jobs. I don't want that headache. This is a self-hosted, self-produced Open edX platform that me and my student manage with the help of these guys, and that's it. So I cannot get it. That's why we're not worrying about that, because it's not something that we can provide. In different scenarios, if you're a multinational institution and you really want to promote your new programming language and create free online courses, and you want to provide cloud for everybody to use it, then you have to talk to somebody else to give you that, technology. There's several offers there.
Because we are worried about students being a little nefarious and submitting stuff like, I don't know, RMRF and other things to the notebook, to the grader, that we don't want to run, on our own, on our own file system. So you could say, okay, well, I'm going to run it with a user that doesn't have permissions to do that. Okay, but then you have other problems, right? And some of them are, is the student going to be filling my instance with garbage content so as to make it unusable for other people? Is the student going to be able to download some binary from somewhere else, which is why we have the network allowed set to false by default. So
it's just to provide a little, fence around the student when they're not actually dealing with this interactively. They're just uploading a Jupyter Notebook, but in the Jupyter Notebook there could be any code.
And you could say, well, we're going to have a long-running instance, but the reason, if you have a long-running instance and you put every student in the same space, then one student, maybe he won't be able to bring down the entire platform, but he'll be able to ruin it for everybody else. So
we have another question over there. I'm sorry, I saw this one first. Go back to you.
Just a quick question. I would love to set this up and try it out in my institution. Has anybody successfully also set this up? Or is it the documentation on the
This is hot off the oven. Man, this is, we put this on GitHub, what, some weeks ago? Or did you try it already?
I have not played with it, but we installed it without any trouble.
Oh, wow. Our first user. Yay!
I just happened to come here before.
There was a question up there, yes.
So does the checking of the Jupyter notebook that it offers that run on the same really
Version 2. At the moment, it's running on the same machine because I'm just trying to save money. Cloud, AWS is expensive. Yeah, it's running on the same machine. Ned, did you want to say something? No? Ah, good. Another question. No, they have no access.
My perspective is that it's an environment with like no dependencies. Like, is there a way for students to download that Docker image?
No. The student has only access to this button here to upload this button here to upload their notebook. That's all they can interact with, upload their notebook. The notebook gets sent by the X block to this Docker image, gets graded, gets sent back, and they see their score. That's it.
So the student has to have their own
Yes. They have to have Jupyter in their machine or use the Jupyter Cloud provision from another source.
And the requirements are, if the student needs some package, then the professor should be able to specify it from the requirements TXT in Studio.
No, I'll provide an assignment that has the right import commands.
Yeah.